So projectile motion. Projectile motion. So what is projectile motion? So in physics, there is a branch called kinematics. Am I right? Kinematics. Kinematics, which deals with the motion of objects. So kinematics is the branch of physics which deals with motion of objects. Motion of the object means that it may be a one-dimensional motion. Okay, one-dimensional motion or two-dimensional motion. Two-dimensional motion. So in the first section of the kinematics, we have studied that is one-dimensional motion. Am I right? One-dimensional motion. So in that motion only we have studied all the physical quantities like displacement, velocity, acceleration. Okay, these are the quantities we have defined. And the equations of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. So these are the equations we have derived, and with the help of these equations we have solved the numericals in one-dimensional motion. So suppose one-dimensional motion is, suppose an object is moving horizontally. Okay, horizontally. If any of the three axes, if any one of the three axes comes into play or is involved with motion, some motion, then it is called one-dimensional motion. Whether it may be a x-axis, y-axis or z-axis. If any one of the axes is involved with motion, then it is called one-dimensional motion. Suppose x-axis, this is an x-axis, an object is moving with a certain velocity. Okay, with a certain velocity v. So we can say that the object is throughout the motion, the x-axis is involved. So y-axis and z-axis is not involved in this motion. At the same time, that is only one of the axis is involved. So such motion is one-dimensional motion. So this is an example for that is 1D motion, one-dimensional motion. Okay, then motion under gravity we have studied. That is, suppose an object is, okay, if an object is projected vertically upwards with a certain velocity. Okay, with a certain velocity. So it goes certain height. Okay, certain height. So when it reaches this point, the velocity becomes 0. Okay, velocity is equal to 0. Then it comes down. Okay, it comes down. So this is also, that is only one of the one axis, that is y-axis is involved in this motion. Okay, y-axis, the motion along, we can say that is y-axis. So this is also, that is one-dimensional motion. One-dimensional motion. Understand? One-dimensional motion. So what is two-dimensional motion? If an object is projected or thrown in a certain angle with the horizontal, okay, horizontal with a certain velocity, then the motion involves, that is two axes at the same time. Okay, the motion is involved with, that is two axes, both x-axis and the y-axis. Such type of motion is known as, that is two-dimensional motion. Okay, two-dimensional motion. So see, so a well-known example for that is a two-dimensional motion is, okay, two-dimensional motion is, that is projectile motion. Okay, projectile motion. So an object is projected from here. okay, from here, with a certain initial velocity u, initial velocity u, at an angle theta with the horizontal x-axis, okay, horizontal, with the horizontal. So then the object makes this path, okay, path. So it undergoes a parabolic path, okay, parabolic path. So this motion involves both axes, that is x-axis and y-axis simultaneously, okay, simultaneously. This motion, that is projectile motion, this motion is called a projectile motion, and this motion is an example for what? Example for two-dimensional motion, okay, two-dimensional motion. So how the object undergoes this motion, that is this object at a certain time, it may be here, okay, it may be here, at a certain, after some time it may be here, at a certain time it may be here, okay. So this is the maximum height reached by the projectile, okay, projectile, maximum height. So after that it comes down, maybe here, here, and finally it reaches the ground. So this is the path followed by the projectile motion, okay, projectile motion. So the projectile motion is an example for two-dimensional motion. So, okay, so first point, that is projectile motion is a two-dimensional motion, two-dimensional motion, two-dimensional motion. It involves both x-axis and y-axis. It involves both x-axis and y-axis. Okay? So projectile motion is the superposition of two motions. Superposition or combined effect of two motions. One is the horizontal motion along the x-axis, and vertical motion along the y-axis. Vertical motion along the y-axis. Okay? So these are the points we can consider in the case of projectile motion. Okay, projectile motion. So the projectile motion is a two-dimensional motion. Okay, two-dimensional motion. So it involves both x-axis and y-axis simultaneously. Okay, simultaneously. It is the horizontal, that is, it is the superposition or combined effect of two motion. Okay, superposition of or combined effect of two motion. Combined effect of two motion. That is, one is horizontal motion along the x-axis and vertical motion along the y-axis. So see here, this ball is projected with initial velocity from this point. Okay, this point. So the ball is going at a certain height. So the y-axis changing. Okay, y-axis changing. That's why that is the ball is going to a certain height. At the same time, the ball is moving from here. So the ball is projected from here. So the ball or the projectile lands at this point. So horizontally, that is at this point. Okay, at this point the ball is here. At this point the ball is here. Horizontally the distance is varying. So y-axis also the distance, that is the height, is varying. The height of the projectile is varying. So that is simultaneously, that is y-axis values are changing as well as the x-axis values are also changing. Okay, changing from the time, as the time goes on. Okay, from the moment the projectile was thrown or projected, as the time goes on, both x-axis and y-axis are changing. So when you consider that is the projectile motion, so it undergoes a parabolic path, that is the object is here, as the time goes on the object is here, so it is the maximum height reached by the projectile. Okay, so after again when the time goes on, it may be here, here. So this is the path followed by the projectile. Okay, path followed by the projectile as time goes on. Okay, time goes on. Suppose if the object is projected with the initial velocity u, okay, initial velocity u, what is the initial horizontal velocity? Horizontal velocity, that is u cos theta. U cos theta. What is the vertical, initial vertical velocity, that is u sin theta. Okay, u sin theta. So u cos theta is the horizontal, initial horizontal velocity, and u sin theta is the initial vertical velocity. So as the time goes on, the velocity, that is the object is undergoing two motions, that is horizontal motion and vertical motion. So that's why the horizontal motion, the object moves horizontally, then only that is the object from this point it comes to this point. Horizontally it is moving. So as the time goes on, from this side here, the height increases. So this is h1 is the height, at this point h1 is the height, at this point h2 is the height, at this point h3 is the height. The height is also varying. When the time goes on, as the time goes on, height is also varying. That is, height is in the vertical axis, that is y-axis. Y-axis is changing. At the same time, the object is moving in this direction also. The object is moving in this direction as well as in this direction also. So both horizontal motion and vertical motion. Okay, vertical motion. Okay. So when you analyze, that is projectile motion, it is the combined effect of that is two motions, so horizontal motion and vertical motion. So we have to make a study on, that is these two motion, that is horizontal motion and vertical motion separately. So the projectile undergoes two motion. One motion is horizontal motion, which is along the x-axis, and another motion is vertical motion. Okay, vertical motion. Vertical motion, that is along the y-axis. Okay, horizontal motion along the x-axis and vertical motion along the y-axis. So initial velocity along the x-axis, initial horizontal velocity, that is ux equal to, what is u cos theta? U cos theta. So what about the horizontal velocity? As the time goes on, the horizontal velocity is constant or not? Throughout the motion, that is the horizontal velocity is constant. Very, very important. In the case of projectile motion, that is the object is moving with a constant velocity in the horizontal direction. Because there is no acceleration. In the horizontal direction, there is no acceleration. The body is not accelerated. The body undergoes, that is constant velocity. Okay, constant velocity. So at this point, that is, it starts with the initial velocity, that is u cos theta. At this point, the velocity is u cos theta. At this point, the horizontal velocity is u cos theta. At this point, the horizontal velocity is u cos theta. At this point, the horizontal velocity is u cos theta. At this point, u cos theta. At this point also, it reaches, that is u cos theta. Clear? So throughout the motion, that is, the horizontal velocity is constant. Horizontal velocity is constant. Acceleration is equal to 0. That is, acceleration in the x direction, ax, that is horizontal direction, is equal to 0. Is equal to 0. Is equal to 0. Okay. So what about the final velocity, that is Vx, equal to u cos theta. U cos theta. So when you analyze the motion in the vertical direction, okay, vertical direction. So what is the initial velocity Vx, sorry Vy, sorry Uy, initial vertical motion, okay, initial velocity Uy is equal to u sin theta. U sin theta. As the time goes on, whether the vertical velocity is constant or not, it's not constant because of acceleration. Each and every point, the acceleration due to gravity is there. Acceleration is in the downward direction, g. In this point, acceleration is there, that is g. In this point, acceleration is there, g. In this point also, that is acceleration, g. In this point, acceleration, g. So in each and every point, the acceleration is acting in the downward direction. Okay, acceleration due to gravity is acting in the downward direction. So the velocity continuously changes. Okay, velocity continuously changes. In the first half of the motion, that is, the velocity decreases. And when it reaches the maximum height, okay, maximum height, the velocity becomes 0. Horizontal velocity is not 0 at that point. Horizontal velocity is still there. Vertical velocity is 0. Vertical velocity is 0. And it goes down, that is, the vertical velocity again increases. Again increases. Okay, so the acceleration is there, that is, acceleration in the y direction is equal to minus g. Acceleration is acting in the downward direction, so minus g, sign convention. Okay, minus g. So what about the velocity? Velocity increases. Velocity increases and it becomes 0. And it becomes 0 when it reaches maximum height. Maximum height. Maximum height. And it reaches the maximum height. When it reaches the, and it starts to increase. And it starts to increase. This is about the velocity in the vertical direction. Okay? So consider the projectile motion. Okay? So consider the projectile motion. A ball is projected from here with initial velocity u. Okay, with initial velocity u. So at an angle theta, the horizontal. So the projectile is going the path followed by the projectile. And here. So this is the path followed by the projectile. Okay. So this is the maximum height, h max. Okay. So this is the u cos theta. So initial velocity in the horizontal direction is u cos theta. And what is the initial velocity in the vertical direction? This is u sin theta. U sin theta. Okay. So we have to derive the expression for that is one time of flight. Time of flight. 2. Maximum height. And the third one, horizontal range. Horizontal range. Okay, so we have to derive the expression for all these things. Okay, so time of flight, maximum height, and horizontal range. So consider the motion, the vertical motion of the projectile. So vertical motion. So this is consider this is point A, and this point B, and this point C. Okay, so the vertical motion. Vertical motion from A to B. Vertical motion A to B. Okay. So I am using the kinematic equation, that is V is equal to U plus AT. Okay, V is equal to U plus AT. So I am writing that is in the vertical motion, that is Vy is equal to Uy plus Ay t. Okay. So what is Vy? Vy is equal to that is the initial velocity, final velocity that is when we consider the vertical motion from A to B, the vertical, that is the final velocity at this point B. So Vy is equal to 0. Uy, so initial velocity at the vertical direction, that is equal to U sin theta. Okay, so Ay is equal to minus G. Okay, minus G. So substitute the values. Vy is equal to, that is 0. Uy, that is U sin theta plus what is minus G into T. Let T be the time taken by the projectile from reaching from this point to that point. Okay, so take this minus gt on this side, so we'll get that is gt is equal to U sin theta. Okay, so from this we have to find the time taken by the projectile from this point to that point. So T is equal to U sin theta divided by G. T is equal to U sin theta by G. Okay, So this is the time taken by the projectile from reaching from A to B. So what is time of flight? We have to find a time of flight. Time of flight means what? The total time taken by the projectile from this point A to C. Time taken by the projectile to reach from start point to the final point. Okay, final point. So we have found that is the half time. Okay, the time taken by the projectile for the half of the motion we have found, that is t. So the time, total time t is equal to, okay, capital T is equal to 2t. So that is the time taken by the projectile to reach the maximum height is equal to time take the projectile for the upward motion is equal to downward motion. So t is equal to 2t. Okay, so therefore the time of flight t is equal to, so what is t small t? That is 2 u sin theta divided by g. So this is the expression for time of flight. So memorize. Okay, so t is equal to 2u sin theta, t is equal to 2u sin theta divided by g. This is the expression for time of flight. Okay. So method 2. Method 2. So I am considering the vertical motion in this projectile motion. I am considering the vertical motion. Vertical motion from A to C. A to C. Okay, A to C. I am using the kinematic equation, that is S is equal to ut plus half at square. Kinematic equation S is equal to ut plus half at square. Okay. So I am rewriting the equation, that is Sy is equal to uyt. Okay, uyt plus half ay t square. Okay, t square. So what is displacement when the projectile starts from this point and when it reaches the point C? What is the displacement? Displacement in the vertical direction. Sy is equal to 0. The distance traveled by the projectile in the vertical direction is not 0, but the displacement, because the projectile, that is the start point, the distance between initial point and final point. So when the projectile is on the x-axis, so on the start, that is the projectile is in the x-axis. At the end, the projectile is in the x-axis only. So the displacement traveled by the projectile is equal to 0. The distance traveled by the projectile in the vertical direction is not 0, but the displacement traveled by the projectile is 0. Very, very important. So Sy is equal to 0. So uy, so the initial velocity in the y direction, that is u sin theta. U sin theta. So t is equal to, here the time is total time of flight, capital T. Okay, so ay is equal to minus g. Okay, minus g. So substitute the values. So Sy 0 is equal to uy, that is u sin theta into capital T minus half, what is ay, that is g. Okay, g. T, capital T, that is t square. So I am bringing this term left hand side, that is half g t square is equal to u sin theta into t. So 1t, this t cancel. Okay, so t is equal to, from this expression, t is equal to 2u sin theta, 2u sin theta divided by g. So this is the expression for time of flight. So the first expression, t is equal to 2u sin theta by g, t is equal to 2u sin theta by g. So both are same. So concept, so that is in both methods we can find that is the time of flight. So very, very important expression for solving the numericals. Sometimes we can directly apply the formula. தூக்கத்துல கூப்பிட்டு கேட்டா கூட சொல்லணும். That is, what is the time of flight? That is t is equal to 2u sin theta by g. T is equal to 2u sin theta by g. Memorize. T is equal to 2u sin theta by g. ठीक है? That is the maximum height. So what is the expression for maximum height? So t is equal to, what is the time of flight? That is t is equal to 2u sin theta divided by g. Memorize it. Okay, memorize it. So maximum height. Next we have to find the expression for maximum height. So again considering the vertical motion of the projectile from A to B. Okay, A to B. So I am using the kinematic equation, that is v square minus u square is equal to 2as. So rewriting the equation, vy square minus uy square is equal to 2ay into sy. Okay, sy. So sy is nothing but what? That is the total distance. Okay, distance, vertical distance traveled by. So we can write that is h max. Okay, h max. So what are the values? Vy. So is equal to 0 when it reaches the point that is B. Vy, that is the final velocity in the vertical direction, is equal to 0. Uy is equal to, what is u sin theta? Ay is equal to minus g. Substitute. So 0 minus u sin theta the whole square. Okay, whole square is equal to 2 into minus g into h max. Okay, so this minus cancel. So u square sin square theta is equal to 2 into h max. Okay, h max. So from this h max is equal to u square sin square theta divided by 2. Okay, this is the expression for the maximum height reached by the projectile. Okay, so h max equal to u square sin square theta, h max, the maximum height reached by the projectile, h max equal to u square sin square theta divided by 2. Okay, 2, not 2, that is 2 into g. Okay, sorry, 2g into, so u square sin square theta divided by 2g. Okay, 2g. Okay, so this is the expression for maximum height. So next we have to derive the expression for, that is horizontal range. Okay, horizontal range. So horizontal range means the horizontal distance covered by the body in the entire motion. So what is the horizontal distance? So this distance, horizontal distance covered by the body. Okay, covered by the body. So I am considering the motion of the projectile, that is horizontal motion I am considering, horizontal motion. Okay, from A to C. Okay, I am using the kinematic equation, that is S is equal to ut plus half at square. Okay, at square. So I am rewriting the equation, that is Sx is equal to ux capital T, because t is the time of flight for the entire motion. What is time of flight? Plus half ax t square. Okay, t square. So what are the values? Sx we have to find, that is the distance covered in the horizontal direction. Ux, that is initial horizontal velocity, that is u cos theta. T, that is time of flight, that is 2u sin theta divided by g. Okay, ax equal to 0. Acceleration in the horizontal direction is equal to 0. Velocity is constant. Acceleration is equal to 0. So throughout the projectile motion, what is the velocity? Horizontal velocity u cos theta, u cos theta, u cos theta, u cos theta, u cos theta. The horizontal velocity is constant. The body is not accelerated. So acceleration is equal to 0. Okay. So substitute the values. So Sx equal to ux, that is u cos theta into time of flight, that is 2u sin theta divided by g into plus half into what is acceleration, that is 0 into t square. So this term becomes 0. So Sx equal to, okay, Sx equal to 2u square cos theta u 2u square cos theta sin theta divided by g, one of the formula. Okay, one of the formula. So trigonometrical relation, that is trigonometrical formula, that is sin 2 theta. What is the formula? Sin 2 theta. Sin 2 theta is equal to 2 sin theta cos theta. 2 sin theta cos theta. So instead of this 2 sin theta cos theta, we can write sin 2 theta. Okay, sin 2 theta. So therefore Sx is equal to, that is 2 u square sin 2 theta divided by g. So you can either use this relation Sx equal to 2u square cos theta sin theta divided by g, horizontal range, or you can use this relation. Okay, this relation. Okay, this relation u square sin 2 theta divided by g. Okay, so this is the expression for, that is horizontal range, that is r. Okay, r is equal to, horizontal range is represented with the letter r. So r is equal to, you can use, that is 2, r is equal to 2 u square sin theta cos theta divided by g, or r is equal to, you can use the formula, that is u square sin 2 theta divided by g. So these are the main expressions in the projectile motion. Okay, so time of flight t is equal to 2u sin theta divided by g, h max equal to u square sin square theta divided by 2g, r is equal to 2u square sin theta cos theta divided by g, r is equal to r is equal to u square sin 2 theta divided by g. So these are the very important expressions regarding the projectile motion, basic expressions. Okay, expressions. ठीक है. So certain points we have to discuss regarding the projectile motion. So first point number 1. So the vertical component of velocity is 0 at the maximum height of the projectile. Vertical component of velocity okay, vertical component of velocity is 0 at the highest point, the maximum height. ठीक है. So when it reaches the maximum height, vertical component of velocity is 0, not the horizontal component. Okay, not the horizontal component. Not the horizontal component. Horizontal component. So horizontal component is not 0. That's why the projectile is moving, still moving from this point. So horizontal component is acting in this direction. So vertical component is 0 at that point. Okay. So the second point, vertical component is positive. Vertical component of velocity is positive when the object is moving up. Okay, moving up. And vertical component is negative. Okay, vertical component of velocity. So vertical component of velocity is positive. Okay, positive when the object is moving up. Okay, moving up. When the object is moving up. Our projectile is moving up. Okay. That point, vertical component of velocity, is negative. Okay, negative when the projectile is moving down. Projectile is moving down. Okay. So what is the fourth point? What is the resultant velocity of the projectile at any intermediate point? So what is the resultant velocity of the projectile in any of the points? Suppose this point. Okay, consider this point. What is the resultant velocity? Okay. So this horizontal velocity is acting in this direction, that is Vx. Okay. Vertical velocity is acting in this direction. Vertical velocity is acting in this direction, that is Vy. So the horizontal resultant velocity is in this direction. So which makes an angle beta. Okay, which makes an angle beta, V. So what is the resultant velocity? So how to find the resultant velocity? So okay, make a parallelogram. Okay, parallelogram here. So the resultant velocity acting as a diagonal. Resultant velocity will act as a diagonal. So the resultant velocity at any point. So V is equal to square root of Vx square plus Vy square plus 2 Vx Vy cos theta. So the angle between Vx and Vy, that is 90 degree. So cos 90 is equal to 0. So this becomes 0. So that's equal to square root of Vx square plus Vy square. Okay? Vy square. So what is Vx? So Vx, so it is velocity in the horizontal direction. It is always constant, that is u cos theta. Velocity in the vertical direction, Vy is equal to V is equal to u plus at, that is Vy is equal to uy. Uy is, that is u sin theta. U sin theta minus, okay, minus g t. So this is the velocity after time t. Okay, after time t. So Vy is equal to u sin theta. Okay, u sin theta minus gt. So that's equal to square root of Vx square, that is u square cos square theta, okay, plus u sin theta minus gt the whole square. So that's equal to square root of Vx, that is u square cos square theta plus u sin theta minus gt the whole square. So that's equal to u square, that's equal to root of u square cos square theta plus a minus b the whole square, u square sin square theta plus g square t square minus 2 u gt sin theta. Okay, so that's equal to u square cos square theta plus u square sin square theta. U square is common, cos square theta plus sin square theta is equal to 1. So root of u square, okay, u square plus g square t square minus 2u gt sin theta. So this is the resultant velocity at any of the point, okay, at any of the points that is in the trajectory of the motion, okay, the projectile motion. So no need to memorize all these formulas. So know the concept, that is how to find the resultant velocity at any of the points of the projectile motion, okay, projectile motion. Know the concept. So understand the way how to find out the values. No need to memorize all these formulas. Okay. So the resultant velocity. So what are the points we have discussed? That is vertical component of velocity is 0 at the maximum height, not the horizontal component. First point. Second point, vertical component of velocity is positive when the object is moving up, when the projectile is moving up. Vertical component of velocity is negative when the projectile is moving down. So the resultant velocity of the projectile at any of the point, okay, v is equal to square root of v square plus vx square plus vy square. So vx equal to u cos theta, vy is equal to u sin theta minus gt. So substitute the values and simplifying. So we are getting that is equal to square root of u square plus g square t square minus 2 u gt sin theta. Okay? So what is the direction of the resultant vector at any of the point? So what is the direction of the resultant velocity? What is the direction of the resultant velocity in the path of the projectile motion in any of the points? Okay, any of the points. So suppose the resultant velocity v makes an angle beta with the horizontal. Okay, with the horizontal at any of the points. So we can find that is tan beta is equal to opposite side, that is Vy divided by Vx, okay, Vx. So what is Vy? Vy is equal to Uy minus Gt, Uy that is u sin theta, okay, u sin theta minus Gt, u sin theta minus Gt. So what is Vx? Vx equal to u cos theta. So substitute, that is tan beta is equal to Vy, that is u sin theta minus Gt divided by u cos theta. So tan of the angle. So tan of the angle we can find. This is the expression to find the tan of the resultant vector. Okay, tan angle of the resultant vector. So the next is you have to derive. So what is the velocity of the projectile when it reaches the ground? When it reaches the ground. So what is the expression for that is ground. So at the point C. So the projectile is coming down like this. Okay, coming down. So the horizontal vertical component is acting like this, that is Vy. So the horizontal component is also there. It is acting like this, that is Vx. Vx. So the resultant velocity will be like this. Okay, like this. Okay. So what is the velocity of the projectile when it reaches the ground? So V is equal to, that is the resultant velocity V. Okay, V. So when it reaches the ground, both horizontal velocity, vertical velocity is acting in this direction, horizontal velocity is acting in this direction. So the projectile, so the resultant velocity will act in this direction. Okay. So what is the velocity? V is equal to square root of Vx square plus Vy square. Okay. So I am taking V square. So V square is equal to Vx square plus Vy square. Okay, Y square. Vx equal to what? Vx equal to Vx, that is u cos theta. So it is constant only, u cos theta. So Vy is equal to uy, that is uy. What is uy? That is u sin theta minus u plus at. So minus g into capital T. Okay, capital T. Am I right? So because here time is the time of flight. Okay, time of flight. That is capital T. So Vy is equal to u sin theta minus V is equal to u plus at. Okay, at. That is minus gt, capital T. Okay, substitute the values. Vx, that is u square cos square theta plus Vy, that is u sin theta minus g capital T the whole square. So that's equal to u square cos square theta, okay, u square cos square theta plus u square sin square theta plus gt square, okay, gt square minus 2u gt sin theta, okay, sin theta. So this u square cos square theta, u square sin square theta, that is cos square theta plus sin square theta is equal to 1. U square is common. So that's equal to u square plus what is capital T? 2u sin theta divided by g. G into 2u sin theta divided by g. So g get cancelled. Okay, g get cancelled. So what will come? That is 2u sin theta. Okay, 2u sin theta the whole square minus 2u into 2u g into what is t? So I am rewriting this here. That's equal to u square, so minus 2u gt sin theta. Okay, sin theta. So that's equal to u square cos square theta plus u square sin square theta is equal to u square. Okay, plus g into t, that is 2u sin theta. Okay, 2u sin theta divided by g. So g get cancelled. Okay, g get cancelled. So 2u sin theta. Okay, 2u sin theta the whole square. 2u sin theta the whole square minus 2u g into what is t? 2u sin theta. 2u sin theta divided by g into sin theta. Okay, sin theta. So g get cancelled. So we can write that is u square plus 2u sin theta the whole square minus. Okay, minus. So we can write that is 2u square sin theta the whole square. So we can write 2u sin theta the whole square. So 2u sin theta whole square minus 2u sin theta whole square cut. So that's equal to that is v square is equal to, we will get that is u square. Okay, u square. So v is equal to square root of u square, that's equal to u. Okay, so when the projectile hits the ground, what is the velocity? What is the resultant velocity? It is same as the velocity it was projected. Okay, so from this what we can understand that the last final velocity is equal to u. So initially the projectile was thrown with the velocity u. So finally it has the velocity, that is u. Okay, clear? So the initial velocity and the final velocity of the projectile is the same. Clear? Maximum horizontal range. Okay, condition for maximum horizontal range. When the projectile is projected from here, so what is the condition for it gets the maximum range? Okay, maximum horizontal range. So what is the formula for that is range? R is equal to, so condition for maximum horizontal range, condition for maximum horizontal range. So what is the formula for horizontal range? R is equal to u square sin 2 theta divided by g. So here u is constant. Okay, u is constant. So projectile is projected with the initial velocity. So g is constant. So it depends on that is sine of the angle. Okay, sine of the angle. So if sine 2 theta is maximum, the range is maximum. Okay, range is maximum. So when sine 2 theta is maximum, so we will get the maximum horizontal range when sine 2 theta is maximum. Okay, sine 2 theta is maximum. So R max, we will get R max when sine 2 theta is maximum. Okay. So when sine 2 theta is maximum, that is sine 2 theta is maximum means sine 2 theta is equal to 1. Okay. So when sine 2 theta is equal to 1, that is 2 theta is equal to 90 degree. Okay. So theta is equal to 45 degree. So this is the angle of projection. Okay, angle of projection. So from this what we can understand, when a projectile is projected with 45 degree, so this angle is 45 degree. So we will get a maximum horizontal range. Okay, horizontal range. So suppose this is, okay, so when a projectile is projected with 45 degree, okay, 45 degree, so we will get the maximum maximum range. Okay, maximum range. So that is theta is equal to 45 degree. Projectile is projected. Okay, so from this. Okay, so this is the condition. Okay, so what is the value for that is maximum range? That is R max equal to that is u square. So sin square theta is equal to 1, u square into 1 divided by g. When you use sin square theta, sin 2 theta, not sin square theta, sin 2 theta is equal to 1, so we will get a maximum range. So R max equal to u square divided by g. So this is the expression for that is maximum range. Okay, maximum range. R max equal to u square divided by 2g. Okay, 2g. So again consider so R is equal to range, R is equal to u square sin 2 theta divided by g. Okay, divided by g. So replacing theta is equal to 90 minus theta. In this expression, replacing theta is equal to 90 minus theta. 90 minus theta. Okay, 90 minus theta. So we will get a new range. Okay, we will get a new range. We are taking that value r dash. So r dash is equal to u square sin 2 into what is theta? That is 90 minus theta divided by g. So that's equal to u square sin 2 into 90, that is 180. 180 minus 2 theta divided by g. Okay. Sin 180 minus theta. What is the value of sin 180 minus theta? Sin 180 minus theta is sin theta. So 90 degree. All silver teacups. Sin 180. So 180 minus theta means in this quadrant. Okay, in this quadrant. 180 minus 2 theta. So here 90 and 270 only the value will change. Okay, conversion takes place. So 90 and 180. Yes, 90 and 270. Okay, 270. So here 180 minus 2 theta means no conversion. So in this quadrant, that is all positive. Here silver, sine and cosec positive. So sine 180 minus 2 theta, sine 180 minus theta, that is sine theta. Okay, sine theta. So we can write here u square. So sine 180 minus 2 theta, that is sine 2 theta. Okay, sine 2 theta divided by g. So r dash is equal to we are getting u square sine 2 theta divided by g. That is r dash. This is the new range is equal to r. So that is sine u square sine 2 theta divided by g. That is r. So that is from this what we can understand. For two angles, that is theta and 90 minus theta. So for a projectile motion, so the projectile angle, so theta and 90 minus theta, we are getting the same range. Okay, 90 minus theta, we are getting the same range. That means if a projectile is projected with 15 degree from the horizontal, for 15 degree and 75 degree, the projectile will get the same horizontal range. If a projectile is projected with 30 degree, okay, 30 degree. So for 30 degree and 60 degree, we will get the same range. Okay. So if a projectile is projected with 40 degree, so 40 degree and 50 degree, we will get the same range. Okay, same range. So pictorially what it can be represented. So we can show that, that is okay. So if a projectile is projected with, that is 15 degree. So this is the range. So this is theta is equal to 15. So for 75 degree we will get the same range. Okay, same for 75 degree of projection. So theta minus, that is 90 minus theta. You will get the same projection. Okay. So if you projected, that is 30 degree, 30 degree. So this is 30 degree. So this is what? Theta is equal to 75 degree. So this is 30 degree. For 30 degree and 60 degree, we will get the same horizontal range. Okay, same horizontal range. So for two angles, okay, two angles, theta and 90 minus theta, so we will get the same range. For theta is equal to 45 degree, we will get the maximum range. Okay, maximum range. So understand. So for two angles, theta and 90 minus theta, we will get the same range. Okay, same range. For two angles, we are getting the same range. For theta is equal to 45 degree, we will get the maximum range. Okay. So again, h is equal to, height of the projectile is equal to u square sin square theta divided by 2g. Suppose the angle of projection theta is equal to 45 degree. Okay, 45 degree. So h is equal to u square sin square 45 degree divided by 2g. So that's equal to u square sin 45, that is 1 by root 2 the whole square divided by 2g. So that's equal to u square by 4g. Okay, u square by 4g. That is h is equal to what is u square by g, that is r max divided by 4. So from this expression, what we can understand? H is equal to R max divided by 4. Suppose if you want to throw a projectile, which should get the maximum range. Okay, maximum range means we should raise the projectile. Is equal to the maximum range divided by 4. Okay. R max divided by 4. So we should throw the projectile in a certain height, that is equal to, that is R max by 4. That is, suppose if you want to throw a projectile, that is should get a maximum range, that is equal to 80 meter. Okay, 80 meter. So the range of the projectile is 80 meter, means 80 divided by 4. So we should raise the projectile, that is 20 meter. So the maximum height of the projectile should be 20 meter. Then only, that is we will get, that is 80 meters of range. Okay. So again, so h is equal to u square sin square theta divided by 2g. So when we get, that is maximum height, that is sin square theta is equal to 1. Okay, sin square theta is equal to 1. So theta is equal to 90 degree. Theta is equal to 90 degree. So we will get, that is h is equal to, that is height of the projectile, h is equal to u square sin square theta divided by 2g. So when we will get, that is the condition for the maximum height is, that is sin square theta is equal to 1. Sin square theta is equal to 1, theta is equal to 90 degree. Okay, theta is equal to 90 degree. Okay, so h is equal to, when we write the expression, that is h is equal to u square divided by u square into 1 divided by 2g. So h is equal to u square divided by 2g. So this is the expression for that is maximum height, h is equal to u square by 2g. So what about this angle? In this angle, what about the range? Okay, range, r is equal to, what is the formula? R is equal to u square sin 2 theta divided by g. So what is the angle? That is theta is equal to 90 degree. So u square sin 180 degree. Okay, 180 degree divided by, that is 2g. So that's equal to 0. Okay, 0. That is, if you want to get the maximum height, means the projectile should be thrown in 90 degree, that is perpendicular. Okay, perpendicular, that is motion under gravity. So perpendicular motion, that is 90 degree we have to project it. So what will come? That is the projectile come in the same place. Okay, so after it goes the maximum height and it will come down in the same height. So the range is equal to 0. Okay, so range is equal to 0. Okay, so these are the things regarding, that is the projectile motion. So concepts we have discussed the projectile motion. So in the next section we will discuss the 10 numericals of projectile motion. Thank you.